Being asked to find a fraction of a shape is a problem that most students will have come across at some point. Today we're going to look at 5 different levels of this type of problem that will get your mind thinking and improve your skills.
The first level, level 1, we're just going to look at shapes that have been dissected into 2 pieces. And this will be very easy for most people. You can see these 3 squares here, they've been cut in half. The area of the white part and the coloured part are exactly the same, so they're all showing a half. So let's move it on. How about these 2 examples? Well, the red example is not a half and the turquoise one is. But the more interesting question is, well, why? And this is because the line doesn't go through the center of the shape, the line that's dissecting the shape, in the red example, whereas in the turquoise one it does. And here's 3 more examples of cutting a shape into 2 parts. These are all halves as well, because the line that cuts them into 2 goes through the center. As a counterexample, this one is not a half, and you can see that the dissecting line doesn't go through the center point. Now you also might get some different types of shapes that are being cut into 2. So you can see that all of these shapes are actually showing as half shaded. And the one on the left, we've got a kind of zigzag line. The one in the middle, we've got a sort of jigsaw shape, so that's a bit more unusual. And the one on the right, the circle's being divided into 2 parts with a curved line. And these are all examples of simple ways to cut a shape into half. Moving on now to level 2 problems. This is similar to level 1, but you have to kind of rearrange the parts a little bit to find the fraction. So for the one on the left, you can see that the band of orange and the semicircle can be flipped to the other side, making half of the shape orange and the bottom half sort of white. The same with this sort of yin-yang symbol in the middle. If we switch the red spot goes into where the black spot is, and we switch those around, you can see that half the shape is clearly shaded. And on the last example on the right, if we flip this little section over to the top right corner, you can see that it makes a quarter, so a quarter of that shape is shaded. And these parts aren't the same size and they're quite irregular, but by rearranging them, you can easily see what fraction of the shape has been shaded. Now we come on to level 3 problems, and these shapes have been cut into multiple parts but of equal size. So here's a simple example. All of these 5 shapes are showing a half, and that's because 2 out of the 4 parts have been shaded, and all the parts are of equal size. And obviously 2 quarters or 2/4 will simplify to a half, and so often we'll simplify the fraction we get to get our final answer. Let's have a look at a few more examples of this type of problem, because within this level you can go from quite simple here to more and more challenging. So this is a regular octagon, and you can see that 6 parts have been shaded, and all of the parts, all these isosceles triangles, are of equal size. And 6 of them have been shaded, but that's out of 8 parts in total. And if we simplify 6/8 by dividing top and bottom by 2, we get 3/4 of this shape has been shaded. Or if you want to do the other way around, a quarter of the shape is white, has not been shaded. What fraction of this shape has been shaded? So this larger triangle has been broken down into 16 smaller triangles, all of equal size. So we've got 16 as our denominator because that's how many sections we have, and 4 of them are being shaded. So 4 over 16. If we simplify this, we divide top and bottom by 4, and we get a quarter of the shape has been shaded. Now we come on to level 4 problems, where each shape will be dissected into parts, but not all of them are going to be shown like the previous level 3 ones we looked at. So have a look at these 2 examples. Now you can see that the example on the left, we have 3 parts here, but they're not all the same size, so we're definitely not thinking about thirds. If we extend this line, you can see that actually there's 4 equal parts and they're all squares. 2 of them are being shaded, and so a half of the whole shape has been shaded. With the one on the right, if we add in these 2 additional lines, we can see that a quarter of this shape has been shaded. Have a look at this example. Here we've got 3 red sections and they're looking quite irregular, and nothing like the squares, the white squares that we have in the rest of the shape. But if we add in extra lines, we can use the white squares as the kind of unit to break down the whole shape into and find out what fraction is shaded. There's 8 parts out of 16 shaded, which simplifies to a half. So half of the whole square is shaded red. And on this, there's a really excellent activity from NRICH called Fractions Rectangle. If you search that on Google, you'll find the activity. And it looks like this. And it actually asks you to find out what fraction each of these numbered parts are out of the whole rectangle. And it's a really great way to sort of practice this idea of dividing the shape up into more areas and trying to figure out what fractions that you're dealing with. So I definitely recommend that. But let's move on to a few more challenging examples of level 4 problems. So here we have a regular hexagon around the outside and this sort of star shape which has been made from equilateral triangles. And the question we want to answer is what fraction of the area of the big hexagon has been shaded blue? So to do this one, I'd first start by counting up the number of triangles, which is 36. And now I'm sort of worried about these extra little bits here. And if I add my equilateral triangles onto that, I can see that there's 2 in the middle, but these little halves here go together. Those parts are actually worth 1 equilateral triangle. And you can see that's because they're half of 2 equilateral triangles. So I know that each of those sections, those triangle sections on the outside, are actually worth 4 equilateral triangles. Those different sections are 4 times 6 because there's 6 of them, which gives us 24. And in the center, we need to know how many triangles are in the middle so we can find out how many triangles are in the whole shape. And if we dissect this and divide it up, we find that there's 12 in the very center. So now we have a total of 72 equilateral triangles making up the area of this hexagon, and 36 of them have been shaded, so that simplifies to a half. And maybe right at the beginning you might have been thinking it looked a little bit like a half, but we need to go through and prove that, and this is one way to do it. So this is a really great question, and it's a slightly simplified version of a UK Maths Challenge question, and it shows us this triangle that's been divided into smaller triangles, and it says what fraction of the large triangle has been shaded. So how are we going to approach this? Well, this triangle in the middle, we can see that's a quarter of the largest triangle. 4 of those will fit into the whole thing. So what about the middle size triangles? Well, we've got a quarter shown here, and that's actually a quarter of the quarter. So a quarter of a quarter is a 16th, and we have 3 of those size triangles, so we need to add 3/16 to our quarter. And now we just need to look at the smallest size triangle, and there, a quarter of a quarter of a quarter, or a quarter of a 16th, so a quarter times a 16th is 1/64, and again there's 3 of those triangles, so we need to add on 3/64. Now, how do we add those fractions together? Well, we need a common denominator of 64, so I'll multiply by 3/16 to get 12/64, multiply my quarter to get 16/64, add all those together, and I'll get 32/64 as my answer. And now we're going to have a look at a level 4 problem, which I've categorized as those that need to be dissected, but they don't show you any of the parts in the original diagram. So you have to do all the work yourself to figure out how you're going to break up the shape. And it's worth saying here that there are many more harder problems which involve fractions of a shape. These are the 4 types of problem that I think students find the most challenging, or at least if they master all of these, they have a really good foundation. So let's have a look at this problem. And I took from inspiration, it's very similar to a problem from Ed Southall's book, Geometry Snacks. So if you want some really challenging problems of this type, I recommend that. So this question, each of the regular hexagons are equally spaced from the center in terms of their size, and we want to find what fraction of the largest hexagon is shaded. So how are we going to do this? We don't have any sections that we could use at the moment, so we're going to have to create some. And you can see that obviously regular hexagons can be constructed from equilateral triangles. So we can use that idea to create this little part that we've dissected up. And this triangle has got 25 parts, and you can see that 14 of them have been shaded in. And so if 14 over 25, if that's the fraction for that sixth of the hexagon, that's the same as the fraction for the whole hexagon. So the whole answer would be 14 over 25. And that's a more challenging problem. But again, it shows where you can take these ideas if you get really comfortable with them and you really enjoy this kind of maths.
So that's it for looking at fractions of a shape. If you have any questions, let me know in the comments. And if you want more maths understanding, especially fractions, check out the Descent Learning channel.